So hello everyone, myself Dr.Mohanakumar KC, working as Assistant Professor in the Department of Mechanical Engineering, ATME College of Engineering, Mysore. So in this video I am going to discuss about the CNC part programming under CNC Turning Program. So under that already I discussed about the program number 1. So this is the program number 2 for the problem statement is write a manual part program for a given part and execute multiple turning and finishing operation. So this is the part. So all the dimensions in the millimeter. So this is the work and machine arrangement. So this is the datum. So here is the origin. So in this direction it will be plus z, and this direction plus x. There is no y coordinate system in turning operation, only x and z. So in this direction z is negative, and in this direction x is positive. So this is the tool entry, how the tool will be entered to do the machining. So this is the syntax for multiple turning and finishing operation. So as it's already discussed the same. So in multiple turning, this is the syntax. So syntax is, it consists of 2 lines, that is the G71. So before writing any program, the programmer should have the basic knowledge of G codes and M codes. So with respect to G codes, G71 is the multiple rough turning operation. So under that G71 U are used for the depth of cut in a step by step, and R for the relief. Similarly, G7 second line syntax, G71 PQUWF. P stands for initial profile. This is the profile of the model. This is the initial profile. That is the block number that will be given by the sequence number, or the from what line of program it starts. This is the initial profile number till it reaches to the final. So in between we are going to have the movement of the tool with the depth of cut of 0.5. that is the P and Q. U and W with respect to this line is the allowance, finishing allowance to be remain for the next operation, that is the fine turning operations. That is the allowance, how much allowance to be retained for the next operations. So this is a rough turning operation, that is with respect to x and z axis, and f is the feed rate. So followed by the fine turning operation, that is the finishing operation, G70. So between the same P and Q profile, initial profile and final profile, and F is the feed rate. So depending on the tool and material combination, surface finishing level, the feed can be for rough turning and fine turning, it can be varied. So in programming, especially when you are going to programming in CAD-M software, so this is the format. Always the program has to begin with percentage symbol, then followed by the O is the symbol to represent the program numbers, then G21, that is the metric unit. G21 is the metric data input, whatever the dimension we are entering in the metric data input, and G20 is the inch similarly, and G98 is the return to initial point cycle for the CAD cycles. Similarly, G28 go to home position, that is where the tool change will going to takes place, that is U0, W0, U and W corresponding with respect to X and Z. Then M06, the tool change miscellaneous function M06 followed by a what tool you want to, at home position it is going to change the required tool. So this is the typical tool that are given in the program. We can select this tool in the software. So followed by once we tool is selected, then the spindle on in forward direction with a speed of 1000 rpm. Then we can have the G00, that is rapid traverse of the tool from the home position to a X100 Z1. So this is the maximum size of the diameter of the workpiece. So X100 means somewhere here, the X in the positive direction it will come, and Z means it is not touch the workpiece, just 1 mm away from the workpiece. With respect to X it is 100, with respect to Z it is Z1, not 0, means it is not touch the workpiece. Then the syntax will be initiated for rough turning operation, that is the G71 followed by the what is the depth of cut. So here we are taken as a 1 mm as a depth of cut and relief 1 mm. Then the second line G71 between the P1 to Q9. So we will explain how the P1 to Q9, and with the allowance for the fine turning operation, that is with respect to x-axis and y-axis, x-axis and z-axis 0.5 and 0.5 corresponding to the x and z-axis with a feed rate of 40. So this is the sequence number. You can add for every line also or from some line also. So that is the sequence number N1, that is the initial block number. So tool has to move to linearly to this position G01, X20, Z0. You can observe here this is the initial diameter 20. So Z0 exactly at this position, X equals 20, positive 20, and Z equals 0. That is the initial block number. Then second one, X30, Z minus 30. You can observe here this is the X30 value, and similarly Z30 value, minus 30 value. Next third line for this position, that is, so until the line 3, that is N3, the tool will move linearly. Once we give the linear interpolation, until we change that any other motion, the tool will be in the same linear interpolation. So Z is, the X remains same here, Z is minus 58. So here onwards the tool motion is going to change. Instead of a linear, it will take a circular path, that is in a clockwise direction. So next line syntax is G02, that is a circular interpolation in clockwise direction. So that is the initial, the final position of the tool, that is X60, 60 value, and Z minus 78 plus 20 is the radius, and previously it is minus 58 plus 20, 78 with a radius of R20, So that is the tool motion. Then once again the tool motion is going to change from the circular interpolation to the linear. Then you have to indicate G01, there is no change in x direction, so only Z value is going to change, Z minus 98, followed by once again there is a tool motion is going to change from linear to the circular, that too in counterclockwise direction. For that G03, X80, Z minus 114 with a radius of 60, followed by next position. Once again there is a change in tool motion from circular interpolation to the linear interpolation, that is there is no change in x value, only Z value, Z minus 134, followed by once again the linear, need not to indicate again and again. So X100, Z minus 154, then the final N9, Z minus 174. So till here the all P1 to Q9 with a depth of cut of 1 mm, the multiple turning will be takes place step by step. It remove the material so that the with allowance of 0.5 mm with respect to X and Z will remain for the fine allowances. So once the operation is completed, so tool has to go to home position, then the tool will be changed with a next tool, the rough turning tool, followed by once the tool change, the spindle will be on in a forward direction with a speed of 800 because it's a fine turning operation. Then corresponding tool will be selected, then fine turning operation current cycle will be repeat, that is a G70 between the P1 to Q9, the same initial profile block to the final profile block with a feed rate. So depending on the surface finish requirement, we can change the speed and feed. Also the depth of cut remaining is 0.5 mm. So once that completed, once again go back to the home position. So U0 W0, here it has one more operation called as parting off, that is a grooving operation. So that is a tool change, the tool change for the parting off of the tool for that operation. This is a reference tool. So once again the spindle forward with a required speed, then tool has to move to rapidly. G00 means the tool motion will be rapidly, the rapidly move with, you can observe here X110, so this is 100, so 110 just above that, and Z minus 174, but here it is going to part of this entire thing from the raw material. So then we have to go, the tool will be here, tool has to move to X0 linearly till here. it has to move with a z value is remains same minus 174. That is, once you move forward, then you have to take it back, then only you have to go to home position. You cannot take it directly to home position, otherwise tool workpiece will be interfaced. So you have to take it to safe position, then only you have to go to the home position. So then we have to go to home position, then spindle stop, program end, rewind for the next operation, and end with the percentage symbol. This is the how the program will be written manually. The same program we are going to simulate in a CAD-M software, that is CNC turning operations. These are how step by step solution for the simulation of the program. The program will be loaded here. Whatever the program I have shown, that will be loaded here. Then we need to select the blank depending on the model, the size of length and diameter. There is no facing operation. Okay. Machines. So here we are going to select a default machine Fanuc based tool, machine tool. Then tools, here 3 tools are required. Tool number 1, add tool, as I shown in the program. The tool should be in mm, the shank size 20 by 20 as I shown in the program. If you want, you can modify the nomenclature. Tool number 2, the first one is the rough turning operation, second one for the fine turning operation. External turn 20 by 20 with a radius 0.4. Here also you can customize the nomenclature. And third one is the parting up, that is a grooving. So add in millimeter, you have to go to the groove, that is external groove 20 by 20. Here we need to take the, and you can modify the length is required is because depending on the size of the workpiece, you have to increase the length, otherwise the tool workpiece will interface takes place. This is the length that the required tools are added. Error check, error check will be displayed here, there is no errors. So solid mode, isometric, so you can vary the speed of the program or simulation. It will take the multiple rough turning operation, first operation. So allowance will be with the fine turning operation 0.5 mm with respect to x and z direction is retaining for the fine turning operation. So rough turning operation is over, then the tool color will be changed. The last parting of option, that is a grooving. So you can see the same thing in the line mode. You can fit the screen. So this is how the depth of cut will be taking place. So this line of program is executing, and the corresponding the coordinate system will be shown here. This is how the simulation of the turning program will be taking place. Thank you.